Welcome to another video tutorial. Today I'm going to teach you how to calculate thermal energy with Q equals M times temperature change times specific heat. Okay. Q is thermal energy and it's measured in joules. M is the mass and it's measured in kilograms. This little triangle in T is the change in temperature. It's measured in degrees Celsius. And C is the specific heat and measured in a funky unit, which is joules divided by kg times degrees Celsius. Okay, so here's an example of calculating thermal energy. I got this from the 5-2 Thermal Energy Transfer 1 notes from Mr. Weiss. And so this one's, a wooden block has a mass of 20.0 kg and a specific heat of 1,700 joules per kg times degrees Celsius. Find out how much thermal energy it would take to warm it from 15.0 degrees Celsius to 25.0 degrees Celsius. So what we are trying to find here is thermal energy. So we are going to write out what we know and what we don't know. Q, which is the thermal energy, we don't know yet. M, which is the mass, is 20.0 kg, or just 20. And temperature change. The temperature change is these two numbers, but you subtract them. As it says here, it takes to warm it. Then if it says warm, then you should get a positive number. So it would be 25 minus 15. You always subtract the second number from the first number. So 25 minus 15 is 10 degrees Celsius. And then C, which is specific heat, that's that funky unit number, 1,700 joules per divided by kg times degrees Celsius. Okay, now our formula is Q equals M triangle TC. Just multiply. Okay, so now we plug things in. 20 kg times 10 degrees Celsius times, I'm going to come over here. I've got room, 1,700 joule kg, zoom out a little bit, times degrees Celsius. Okay, now we just multiply all of them together and we get 340,000. And now we're going to try to figure out how to get the unit, because there's like so many units in here. So we'll do kg times degrees Celsius times joule per kg times degrees Celsius. Now we're going to put these over 1, and we're just going to cross out. So these two cross out, these two cross out, and what we have left is joules over 1, which is basically joules. So that means our units is joules. So that is our answer, and that's how you solve solve thermal energy. Yeah. From the previous slide, I told you the wrong information about where to get these problems. These problems are from 5-1 Thermal Energy, Temperature and Heat 2. Okay, anyways, so this is another problem, but with remember from the other slide where it said warms right here, but now it says cools. So this one's going to be a little bit different, but not as much. So let's start. Okay, first off, let's find what we know and what we don't know. So Q equals, which is the thermal energy, and we don't know that. And then M, mass, is 50 kg. And then the change in temperature. Okay, so since it's cooling, the answer is going to be negative. Well, the number is going to be negative when you subtract from these two numbers. So from the last slide, I said you should subtract from the second number to the first number. So 20 minus 30 is negative 10. So the change in temperature is negative 10 degrees Celsius. Okay, and then the specific heat is right here, that funky little unit number, and it's 1,000 joules divided by kg times degrees Celsius. Okay, now we are going to use this formula. Q equals M times change in temperature times specific heat, and then we plug things in. So Q equals 50 kg times negative 10 degrees Celsius times, I'm going to come over here again because I ain't got no room, 1,000 joules per kg times degrees Celsius. There we go. Okay, now we're going to multiply all of them together, and we get negative 500,000, and then the units. So kg times degrees Celsius times joules over kg times degrees Celsius. Put these over 1, cancel them out. Joules over 1, and we have joules left, so our unit is joules. It's as simple as that. It's not that hard, it's really simple. Just think it through and you'll get it. Awesome. Okay, now we are going to find the specific heat in this problem. Okay? So now we're going to write down what we know and what we don't know. Q, which is the thermal energy, and the thermal energy is 2,000 joules, and then the mass, 2 kilograms. Change in temperature, that's 5 degrees Celsius, and then C, which is specific heat, and that's what we do not know and what we want to find. So that means we have to change our formula, and we need to change our formula. And how do we find that? Well, I'll tell you. First, write down the original problem. Okay, let's circle what we want to find. And now we're just going to divide on each side, because the equal signs means to do the same thing on each side. Okay, so now we just cross things out, cross, which equals C equals Q divided by M times change of temperature. So that's our formula. Okay, zoom out a little bit. Okay, so C equals Q divided by M times change in temperature. Let's plug things in now. C equals 2,000 joules divided by 2 kg times 5 degrees Celsius. Okay, now let's solve it. So C equals 2,000 joules. So 2 times 5, 10 kg times degrees Celsius is just kg times degrees Celsius. Okay? Now, the answer, just divide it, and you'll get 200. And for the units, just plug them down. So it's joules over kg times degrees Celsius as our unit. And so this is our answer. So that's how you find specific heat. Thank you.